examination, okay, for the Pine Mountain examination, okay. 这样你记得期中考考哪 ？So, multi component, okay, multi composition, centering, okay. So this slide is very important, okay. If I give you this slides, I just mark this. Okay, so you need to fill in the correct term, okay? So you need to get a explanation. So which one is the best for the centering? Do you remember that? This one. Right? Then following by the whole generate to this one, okay? This one, inhibit. And this one is decrease. It's not good for the centering, right? This one is the same, right? This one is increase, right? Do you remember this? Enhance centering, okay? So this one is, then this one is inhibit, so it decrease a bit. So this decrease more. Okay, more. Something like that. Okay, something like that. Okay, so this is a homogenization, right? So this one is very important. Okay, so maybe by this figure you need to know this one is homogenization. Okay, homogenization, you can see the characteristic is the density is constant with increasing of the temperature. Okay, or increasing over time. Okay, but the properties change. The property change. Because the chemical composition is also changed. It's something like homogeneous. This one is less homogeneous, here is homogeneous. So you can see homogeneous, the hardness is better than the non-homogeneous, okay? Than the non-homogeneous. Okay. It's also very interesting, okay? So this one for the enhance. So for the dopant, right? Do you think here this one is a pure tungsten right here? Pure tungsten, okay? But if you dope with different dopants, so you can see will be enhanced, okay? Enhance. This one will be inhibit. So you have the zirconia, alumina, right? Because they are no good solubility. Both solubility are low, so you can see. So the final density is not so good. Inhibit. Okay. Bye. So then here, okay. Oh, not here. For the viscosity sintering, I think only one important point is you need to describe about the Franco model and the MS model, okay, and the Schultz model. You need to know the difference between these models. So both models are described about different stage, okay. I think that is very easy to understand. Then another one is about the grain growth and the microstructure control. Okay, the most important this one is about you need to describe about the normal grain growth and the abnormal grain growth, right? About how the description, okay? About the normal grain growth, do you remember about the distribution is very narrow through the whole sintering process. Okay, so we call the normal distribution, normal grain growth. So you can see in there. Another definition is your average grain size need to be the largest grain size. Two types of grain average grain size need to be smaller, okay? Need to be smaller. Smaller, okay? Smaller. The second one is about abnormal grain growth. Abnormal grain growth is during for the sintering process, you may have a bimodal distribution. Bimodal. Here we call it bimodal distribution. Bimodal distribution means you need to use the two average grain size to represent. One average grain size for the small grain, one average grain size for the larger grain. Then the definition is larger grain size larger than the 2 times of average grain size. Okay, is we call the abnormal grain growth. Okay, abnormal grain growth, something like that. Oh, this one, larger than the average grain size. Okay? Average grain size. Abnormal grain growth. So these are very important. Okay, these are very important. Also very important, this one is the 4 reasons for the abnormal grain growth. Okay, 4 reasons. The first reason is impurity. Okay. Then the second reason is liquid phase. Liquid phase. Then remember, impurity and the liquid phase, they need to be non-homogeneous distribute. If your impurity is homogeneous distributes, every grain abnormal grain, so they also normal grain growth, right? Because the impurity amount is very small amount, so it's impossible to homogeneous distribute. Okay, for the impurities. Okay, for the liquid phase also. Okay, for liquid phase. So if liquid phase, it also need to be not homogeneous distribution in your metric system. Okay. The third one will be dislocation. Dislocation also a possible reason for abnormal grain growth. Okay, for abnormal grain growth. Final is about an isotropic of the surface energy. An isotropic of the surface energy. Some surface have the higher energy, so we will grow faster. Some surface have a lower energy, so will grow slower. Okay, because the lower energy is stable. Okay, so these 4 reasons. Right? Okay, so also something like Archimedes method you need to know. Okay. Also that is the advantage and disadvantage of Archimedes method. Then also the SEM, okay? SEM methods, okay? SEM method, okay? Another one is the pore size, okay? So this one is okay. Skip this, skip. Okay, skip this. Okay, as for ripening, so it's also very important. Please give a proper explanation of the as for ripening. Okay, as for ripening is theory to describe about the grain evolution. Okay, grain evolution. So the grain surrounded by the environment. So environment can be the solid or liquid, right? So finally, bigger grain will become bigger, small grain will become smaller. So it's very easy. Something like that. Okay, so small will be disappear, right? Through the environment. So you can see here we have the darker region. Okay, so this is as for ripening. Okay, as for ripening. So as for ripening, we have the 2 mechanisms. Okay, the first mechanism will be 2 control steps. The first one will be reaction control. The second one will be diffusion control. Then the two mechanisms, they have a different particle size distribution. The narrower will be the diffusion control because they have more time for the diffuse. The broadened distribution will regarding to the reaction control because not too much particle are go and react. So small particle remain resistance. Okay? So reaction control. Okay? This one goes. This one. Okay? The topological approach is also very important. Okay? You need to explain about this. F is phase, right? E remain for the edge. To remember this. Phase. This one two phase. E is edge, right? Edge. This one is edge. Then the V is vertex. Vertex. I will randomly give you maybe I randomly give you some strange figure, something like that. So please calculate about the F, E, and the V, something like that. Okay, so it's very easy. Okay. Okay, so you can see that for this one, if your phase is smaller than the 6, you will be disappear. Your grain size will become smaller and smaller. If you're larger than the 6, you will grow. Okay, so this one's a topological approach. Okay. Okay, so this is easy. Okay, normal grain goals already mentioned. Okay, so I think that's all. So let me see the next. Okay, liquid phase sintering are very important. Okay, this one. Okay, the solubility between liquid and solid. What the interaction we need to focus on here. Okay, so this is also very important. Okay, so we may have the swelling effect or the densification. Then here is we call it extensive densification. So we'll improve a lot. But sometimes, okay? So it's something we want to notice about it. Okay, about the phase diagram here. If I random put a point here, you need to say this one is solid state sintering, or viscous sintering, or liquid phase sintering. Over here. We here. Okay. The final here is also very important. Do you remember here? A typical image for the liquid phase sintering. Do you remember that? We have the two characteristics you need to mention. The first one, we have the very flat liquid, okay? Very flat liquid, okay? Very flat liquid. The second one, you can see the crystals. We have the very smooth surface, smooth surface, okay? So what is smooth surface? We can go to the oh, sorry, I didn't download it. Okay, but from that image, you can find, right, you can find here, you can find this structure, and you can find this structure, okay? Find different structure. You can find different structure. 不知道还在不在啊？不在了。